So I chose to do problem number 19, which says that two blocks are free to slide along the frictionless wooden track ABC, shown in figure P9-19. The block of mass M1, 5 kilograms, is released from point A. Protruding from its front end is the north pole of a strong magnet, which is repelling the north pole of an identical magnet embedded in the back end of block mass M2, 10 kilograms, initially at rest. The two blocks never touch. Calculate the maximum point to which M1 rises after the elastic collision. Okay, so first of all, I kind of redrew the diagram over here. And the first thing that I want to figure out, if I'm going to use conservation of momentum, I have to figure out the speed at which M1 is going when it hits, well, it doesn't actually hit, but until it pretty much hits block M2. So we know that it starts with only potential energy, and it all goes into kinetic energy at the bottom of the slide. So mgh is 1/2 mv squared, and when you solve that, you get the velocity is 9.9 meters per second. And we're going to make that way positive. So once I know the speed of block M1 at the bottom, we can do a conservation of momentum problem. And since it's an elastic collision, we know that M1v1 plus M2v2, but M2v2 is going to be 0 because it's not moving, so I just chose not to include that. M1v1 is going to be equal to M1 velocity final and M2 velocity final. So you plug some numbers in and you get 49.5 kilograms meters per second is equal to 5 kilograms times the velocity 1 final plus 10 kilograms times velocity 2 final. And since we know that this is an elastic collision, we know that kinetic energy is conserved after the collision. And I chose to use the kind of hack equation here because I don't want to write out all the 1/2 mv squareds. So velocity 1 minus velocity 2 is going to be equal to negative velocity 1 final minus velocity 2 final. Because we know that we have two unknowns in this equation, so we're going to have to use some substitution here. So I solve, 9.9 meters per second, because velocity 2 is obviously going to be 0. And so then I solve it out, and velocity 2 final is equal to 9.9 meters per second plus velocity 1 final. So if I input that in for velocity 2 in my first equation that I had here for conservation of momentum, I get this whole equation, and then when I solve that for velocity 1 final, I get negative 3.3 meters per second. So we know that right after the collision, this first block is going to be going negative 3.3 meters per second. So it's going to be going that way at 3.3 meters per second. And then the question is asking what height will M1 rise, because it's going to go up this slide, right? It's not going to go straight. It's going to go up this slide. So this is another conservation of energy problem. So it's going to go from all kinetic to all gravitational potential. So it's basically the inverse of this. So 1/2 mv squared is equal to mgh. And if it's going 3.3 meters per second, it's going to rise to a height of 0.56 meters, which is your answer.